Right, so at this point, we know how to write names and formulas of all different types of compounds. So the next step we're going to do is be able to calculate the percent composition of the elements in those compounds that we now know how to write names and formulas of. So percent composition describes the percentage that an element makes up of a compound. It is consistent. It never changes because of the law of definite proportions, which just states that a chemical compound is always composed of the same elements in the same ratio by mass. Okay, so that's just stating that, like, for example, water is always made of 2 atoms of hydrogen and 1 atom of oxygen. The percent composition of water is always the same. So the mass of hydrogen, the percent of hydrogen by mass is always the same in water. So no matter how much water you have, that percentage is always going to be the same, which is kind of nice because then we can work backwards. If we have an unknown compound, we can work backwards and try to figure out the identity of that compound by analyzing it and seeing what percentage that pure substance has of each element, and you can work backwards and find the ratio of the different atoms in that element, thus getting the chemical formula. So percent composition is the percentage by mass that a particular element is in a compound. So we'll put that in. So these calculations are not hard. We are doing percentage calculations, nothing more than part divided by whole, where your part is going to be the element in question and your whole is going to be the molar mass of the whole compound. So you're calculating molar mass. To calculate molar mass, you're going to look up the element's molar mass on your periodic table. So you'll need to have your periodic table out, and unless you're doing the calculations in your head, you may want a calculator. Okay? So you're going to find the molar mass of each element and multiply that by the number of atoms of that element, and then divide by the total molar mass. So it's part divided by whole times 100 will get you percent composition. We'll round our answers, since we're working off of our periodic tables, to the nearest 0.01%. Okay? So the percent composition formula, if you really want to call it a formula, is this right here. You can put this on your purple sheet if you want to. Okay? You're really just doing a percentage. You're taking the part, which is the element molar mass, times the number of atoms in the compound, divided by the total molar mass of the compound. So for our first example, we're going to work out the percent composition of each element in calcium nitrate. So first step is you're going to calculate the molar mass of calcium nitrate, of CaNO3 2. So just a reminder, you'll look up the molar mass of calcium on the periodic table, which is 40.08 grams per mole, and you'll multiply that times 1, plus the molar mass of nitrogen, which is 14.01, and you'll multiply that by 2, because remember this subscript 2 distributes to each of these. Okay? Plus the molar mass of oxygen, which will round to 16, times 6, 2 times 3. Okay? And our total molar mass, you might want to pause the video and make sure that you can work this out and you know where all those masses came from. Total molar mass is going to be 164.10 grams, or something very close to that. And that's going to be units of grams per mole. Then to get the percent of, we're going to do percent of calcium first. So you're going to take, since there's only one calcium atom, times 40.08, and divide that by the total molar mass of 164.10. So it's part divided by whole times 100. Then do the same thing for nitrogen. So we will take 2 atoms of nitrogen in the formula times the molar mass divided by the total of 164.10 times 100 to get that percentage. And then we'll do the same thing for oxygen. So you'll have 6 oxygens in the formula times 16 divided by your total molar mass of 164.10 times 100. And you can pause the video and go ahead and calculate these, but we're rounding to the hundredths place with each of our percentages. So it should be like around 24.42% calcium, do the percent and the label. This should be around 17.07% nitrogen, and oxygen you should get around 58.50% oxygen. Okay. So our next example problem we're going to do is with a type of ionic compound that's called a hydrate. Okay, so this is barium hydroxide, and you'll notice that you'll see a middle dot. That middle dot means and. Okay, so a plus. So think of the middle dot as a plus sign. And 8 waters. So each barium hydroxide has 8 waters attached to it. We could get rid of those waters by heating them and heating the barium hydroxide hydrate and removing those waters. And with hydrates, a lot of times that causes a color change. Okay? So a hydrate is a ionic compound, or also known as a salt, that binds a certain number of water molecules to its crystals. So that bind or attach water molecules to its crystals. Okay, now naming these, not much different. You're going to name the ionic compound. So this is barium hydroxide. And then you're going to name the hydrate. So you have an 8 here. So that's octa. And then you'll just write hydrate. So to name a hydrate, you're going to name the ionic compound, then you're going to use a prefix for the number of waters, and then write the word hydrate. Okay. Now, if we want the percent of water, we need to get the molar mass of the whole thing. So you're going to get the molar mass of the barium hydroxide. Then you're going to get the mass of 8 waters. So you can do the molar mass of 1 water and multiply it by 8. Okay. Then you're going to add all of that up. Okay. So the barium hydroxide by itself, weighs 171.35 grams per mole. So that's 1 barium, 2 oxygens, 2 hydrogens. Then the mass of the 8 waters, so 1 water is 18.02 grams. Multiply that by 8, we get 144.16 grams per mole. So this is barium hydroxide octahydrate. So that middle dot right here means and. So you're going to add these two together. So the total molar mass of this compound, of this hydrate, is 315.51 grams per mole. So the part, the 8, if we want to do the percent of water, we're going to take the mass of the waters, so 144.16, divided by the mass of the whole thing, 315.51, and multiply that by 100, and we get a percentage of around 45.69%, percent water. Okay. So we're going to calculate the percent of oxygen in this formula. Now there is a typo here. We need to fix this. This is Na2CO3. So again, we have a hydrate. This is called sodium carbonate. And then because there's 10 waters, decahydrate. Okay. So we're going to get the molar mass of this whole compound right here. So you do the sodium carbonate and then the decahydrate. you should get a total molar mass of 286.21 grams per mole. So I'm going to pause the video and go ahead and add up 2 sodiums, 1 carbon, 3 oxygens, and then 10 waters. Water is 18.02 grams per mole. Now this time we want the percent of oxygen. You'll notice there's 3 oxygens here, and then there's 10 waters for another 10. So we have 13 oxygens. So I'm going to take 13 oxygens times the molar mass of oxygen divided by the molar mass of the hydrate, 286.21. Multiply that by 100, and we should get around 72.67% oxygen. Okay. All right, so one more type of problem down here. So we're going to go from mass. So we're going to find the mass of calcium in 75 grams of calcium hydroxide. So what's consistent about this calcium hydroxide is the percent by mass that calcium is of this compound. So I'm going to find the percent composition of calcium in calcium hydroxide first. So you're going to get the molar mass of calcium hydroxide. So 1 calcium, 2 oxygens, 2 hydrogens. So that is 74.10 grams per mole. That is your whole. So we're going to take the mass of calcium, 40.08 grams, right off the periodic table, divided by the molar mass of the whole thing, 74.10. Multiply it by 100, and we get 54.09% calcium. Okay. So to find the mass of calcium that's in 75 grams, well, I know that 54.09% of the 75 grams is calcium. So I think the way you guys have been taught to set this up is to take the percentage, 54.09, out of 100. So think about if I had 100 grams of calcium hydroxide, there would be 54.09 grams of calcium. Set that equal to how many grams of calcium, so X grams of calcium out of 75 grams of calcium hydroxide. So this is 54.09, think of it as grams of calcium in 100 grams of calcium hydroxide. So I want to know how many grams of calcium if I have 75 grams of calcium hydroxide. This percentage, 54.09, is always the same for this compound. It is consistent. So you're just going to cross multiply and divide. And with correct sig figs, because a 75 is a measured number, has 2 sig figs, you should get 41 grams of calcium. Okay. So the next thing you do is work some practice problems on pages 15 and 16. When you do molar mass, you do not need to show all of your work. You can do molar mass right in your calculator and then just show your setup for percent composition.